Well, I thought I'd do a little video on my latest project that's about to be completed. It's my pick and place machine, but then I got to thinking that I never did a video on my tennis ball shooter. So we're going to take the pick and place off the table and pull a tennis ball shooter up there, and we're going to talk about it while I still remember what I did. Well, this is what got me started on this. Ashley found this on the internet, this Kickstarter, the Slinger deal. They have 2,815 backers that have pledged $731,000. She got in on the early bird special, $219. Okay, and it's to be delivered October 2018, and it's July of 2019. Well, they missed their goal. But anyway, this is what got me into my project. So anyway, it was fun. About a year ago, and it's about the middle of July 2019, Ashley started playing tennis, and Kickstarter had a tennis ball shooter on there for a couple $100, and she put her money in on it and hasn't gotten it yet. It might be delivered, that was 2018, it might be delivered at the end of 2019, but anyway, she hasn't gotten it yet. But I thought, well, let me make an attempt at building one, and it started out where it was going to be just a simple thing, where you have a motor and a ball and a snubber, and the balls fall in and it gets shot up, and you basically just kind of move the thing around and point it to a place you want the ball to land, and a real simplified unit, and that's basically what she's getting. But yeah, as I started out playing with this thing, using a single motor, I found out it didn't work very well. It always put spin on the ball, which was okay, but it was always the same type of ball, and it just didn't shoot the ball very fast. So I really wasn't pleased with it. So I started working on this, and of course it involved in the simple turn it on machine to a machine that has a liquid crystal display, and shows you how much I played with it. Turn it on. It has a startup screen, and I don't know if all that's going to show or not. But anyway, we can go through different. There's an interlock. If I don't have the key plugged in, it's locked in place till I pull the pin, put the pin in. That activates things, and then we're allowed to go on to the next menu. I'll show the menus later on off the computer, and you'll get a little better idea. But I had to design the case for this and do all the programming and stuff. I'm not going to turn it on here more than that. But anyway, that's the gist of the machine. There, and keep rotating it around here. One of the hardest things to do. See if those batteries show. The hardest things to do is powering a portable unit. I mean, there's plenty of batteries around, but the best batteries, I needed a 20-volt battery. The best batteries you can use are the lithium-ion, lithium polymer, but with using those, you end up with the danger of charging them and how to manage the use of the battery. So what I did was I made a battery holder that will take the standard DeWalt battery packs, and this is the spare battery, and this is the active battery. So when that one goes down, I put that one in. This is the interlock I spoke of here. That arms the system, and when you're traveling, to keep this thing from flopping all around and banging the stops, I put the pin in there and it locks it. So okay, well, now let's take off the blue jean cover here. It's just a simple cover of snaps that hides all the goodies. we can get on the inside of things here. Let me see if we can lower this a little bit. All right, and we'll come around. Okay, here we are, looking down the throat of it. And as I say, I started out with one motor and a stubber. I didn't like that. And then I went to 2 motors, and when I got into 2 motors, then I started messing with different wheels. I bought some solid rubber wheels from Harbor Freight and turned them down on the lathe. And as soon as I turned them down on the lathe, I found out they aren't completely hollow. So whatever, I thought, well, I'll try them anyway. And when I spun them up, well, the rubber came right off the hub. That was the end of that. So I had to find a good rubber wheel that was high speed, and I found these. These are downhill wheels on large scooters, or what do you call them? Skateboards. Big ones. They're like 6-inch wheels, but I turned them flat and put them in here. This is just a piece of 3-inch PVC, and I kind of designed it around that. And you'll see that there's 2 motors, one here and one up here. Oh, we got all this centered up here. They're 400 kV motors, and I'm running 20 volts. So that at the high end would give me 8,000 revolutions. You could calculate the speed, the surface speed of the wheel, if you want to do the math. It turns out a 400 kV motor throws the ball about 50 miles an hour with the battery that I'm using, which is you're probably getting 18 volts battery power. So I can make it shoot faster by either increasing the battery voltage or by changing out the motors. The motors are just, they're a 55 motor. These are G-force motors, nothing special. But the shafts have been taken out of them, and I put an extended shaft on them. And I didn't feel like that just a basic shaft could support the wheel and take the bangs and knocks. So the extended shaft has a bearing support on the far side. So, and there are these 2 plates. These and these are identical. And for some reason, I see this one's aluminum and the other. No, this one's aluminum. This one, and those are. I don't know why I did that. There must have been a reason for not using. This is 1/8-inch fiberglass. This is 1/8-inch 6061. I don't know why I did that, but there's some reason. Anyway, I forgot. On the end, I didn't realize how complicated this all was going to get, but when you drop a ball down in there, the machine that delivers the balls doesn't always deliver a ball. So you have to, when it rotates and it puts the hole there and the ball doesn't drop, I can sense that with a photo sensor. There's one at the inlet on the other side here. You go to the inlet here, okay. When the ball drops in, there's a photo sensor that says, okay, actually the sensor's right up here. When the ball falls, is okay, we've got a ball. And then the sensor here says, okay, I shot a ball. And this sensor here measures how long the photo interrupter is been interrupted, and it can give me an estimate of what the velocity of the ball is. I don't know how accurate it is, but anyway. Let's see what else is going on here. Obviously, it went through several stages. The first stage was make something that shoots a ball, okay? Then the second stage, and probably one of the longer stages, was designing the mechanism that, drops a silly ball in there. I went through several different ones. They clog up and they wouldn't work, or they didn't have enough torque or whatever. And I finally ended up using a geared motor and I created a couple of gears up in here to increase the torque, and then a couple of sensors to sense where the hole positions are. And I made that all play, but I messed around a long time with the ball feeder, and I'll show some video later on the balls going into the feeder. Once in a while the ball would get stuck, and you'd basically either have to go again to try to get another ball, or at times the ball would fall halfway in and then get cogged up. So I had a timer there that when it did, it would back up just a little bit, let the ball fall, and then continue on. And the ball feeder, I battled with that thing, but finally it's been very reliable, so I'm happy with that. The fact that I have two motors allows me to have top spin and bottom spin, and of course I can control the pitch of the mechanism. Here's just a standard RC servo here. That happens to be a Fatava S3302 that controls the pitch. Okay, and then it might not be very easy to see down in here. See if it shows up. Down here are two servos. Those are Hi-Tech HS755s that are in parallel that guide it left and right. So when you first turn it on, the first thing you do is you set it down and hit a test ball and make sure it's in the right direction. And if it's not, you just basically move the machine to get it to hit the center. And then you run the tilt up until you get it just to go over the net. And then you hit calibrate, and that's the starting position, and it should know from there on where to to pitch and how much power to give. You can vary the power, way down or way up, so you can either lob a ball or you can really smoke it. And I didn't think the balls would be that hard to hit, but I'm amazed. I went out and swung at a few of them, and it's a good training device. The motors are controlled by just a standard RC servo speed control. Nothing special about those. I had trouble getting two of them that didn't have a brake on them. I don't want it to brake, I want it to coast. So I finally found those. The controller is a teensy 3.2, which is right down in here. Let's see if we can get a little better picture of that. Here's a teensy 3.2. And then to drive the motor that starts the balls, I have a Dimension Engineering driver that will drive that, and just sensing the position of the switches and the photocells. The servos are just pulse width driven right off the teensy. That's simple enough. I found out that I had a hard time. I had oscillation. There's enough mass here. This whole left-right mechanism is supported by the two bearings down in here. And there's enough weight that I would have a little bit of wiggle when it got to the end because I didn't have enough torque on the one servo. So I added two servos, did a little mechanical mixing assembly up here, so that if the servos, since I don't have them electronically balanced, but it does balance them, so if one goes a little farther than the other, they don't fight each other. And they go and give me my left and right. And then I added a little circuit board here, and I don't know who makes it. It says servo speed reducer. Basically what it does is I tell it to go to a certain pulse width position, and it slowly finds that position. So instead of it going and then oscillating a while, it kind of goes okay. Originally I had my own home-built servos that had plenty of moxie to move it around, but they weren't quite fast enough. So instead of re-engineering those, and since I was getting so deep into this silly project, I just put a couple RC servos on there, and they're okay. I think I could strip the gears if I back drove them too much, and that's one of the reasons I have a lock pin, so that when it's not being used, it locks them in place, so we aren't reverse driving them. The code, I don't know. the hardest part of the code really was talking to the remote display. I think I spent more time on that. There's a couple thousand lines of code, but written in C, but it's most of the code is for talking to the screen and the code that's written to sort the balls so that you know if you've got a ball and did it shoot and so forth. But other than that, why, that's the basic gist of it. If we this box I made just took some foam and took some foam and basically I took foam and laid fiberglass on it and made it to fit this basic wooden frame, which as you can see is a prototype. And I laid this out on a 3D printer and printed it, but I ended up adding things to it and filler and stuff, and this little stir I add to it, and this keeps the balls when the unit is right over a hole. This is to keep other balls from just falling on through. Otherwise, you get boom, 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 boom. You shoot any ball that happened to fall in there. So that's to prevent that. This stirs it. Anyway, it's worked out pretty good. That part of the mechanism has been fine. Battery system has worked out really well. So pretty pleased with that. This little box here is just a 432 remote control box, and it allows the person to put it into a position, walk to the under end of the court, hit it, shoot balls, and if they get tired, they can hit it and stop it, and whatever. So I don't think we've used it, but it is there. It's got 4 relays, and they're in a latching mode, and I can command it to do the calibration remotely and whatever. So anyway, that was pretty straightforward. Well, that's about the gist of it. Let's go into the computer. We can show some of the general drawings and stuff and what I did to get this far. Okay, let's look at some of the stuff I did on the computer to create the machine. So we'll get onto the computer screen here. Let's open up Fusion, and which I had running, and look at a few of the little items. Of course, you got to draw the parts you're going to use. So that's the motor I used, and then you make all these little assemblies, a lot of which are printed on a 3D printer. This is just the photocell sensor. This is the ball sorter, and it's got changed many times. I ended up taking all this top stuff off and just putting one little stir in the middle, and that turned out to be better. So it was kind of an iterative process before I got what I want. Matter of fact, probably took me a couple months to get the ball sorter to work. Yeah, you make a little servo mount for a couple servos. Here's just a couple of the basic parts for making the motor drive assembly. The motor, of course, sits on this plate here, and there's a bearing, idler bearing on the far side of the shaft, the wheel, and then what Fusion makes it nice where you can create these complex shapes like this, which basically mounts to the plate and then has a radius and a surface that mounts to the PVC pipe. Okay, and you can see a couple little different brackets that I've had to make that fit the pipe to hold different things. This is the drive motor assembly, basically just a geared motor that drives another gear to get it down even slower. And this, of course, rotates, and there is a detent here, and when this micro switch here sees the detent, it stops. So, and that's the gear ratio is such that it rotates the motor 90 degrees. There's 4 holes, and it selects and puts a different hole with a ball in it, hopefully, and drops down through the hole. So that's the basic, some of the basic things of the motor mechanism. The code was written in C using a Teensy 3.2. It's a little microcontroller. Runs about, I think they run about 80 megahertz. It's a fairly good controller, reliable, and the support's real good. It's basically a state machine, and it runs itself in one of these different, what do I got, 7 different states. It's either in the calibrate mode where it starts out, where you get done calibrating, and it just sits in system run 99% of the time until you ask for something. And if you ask for a ball, it's in request, and it waits till the ball, did the ball drop? If not, it keeps going. Did I get a ball? Did it shoot the ball? And then if there's a ball jam, it does some things to get out of that. So, basically there's about 2,000 lines of code. About half of it had to do with talking to this Nextion display, which makes it easier to create displays and graphics, but it does take a lot of interface code to get it to do what you want. This is the initial page you get when it starts up, and I had pictures and stuff on there at first, but I gave up. Every time I changed it, I'd have to re-edit everything, so I got tired of that. Here's the original calibration page where you shoot a ball, and then you either set it higher or lower, or physically move the machine left or right. And when you're done, it goes on and displays the main page. All of these are different types of shots: beginning, good, advanced, moon, hook, lefty. SSRPT is basically a single shot that you can repeat. So you pick where you want it to be, and it'll continually just shoot shots there over and over and over again. These are for calibration, how long between the shots, and some other setup functions. This is the page you use to tweak a individual shot where you might want it to be, adjusting the power, the tilt, the spin on the ball, and whether it's left or right. And there's various pages. I have 8 locations on the court, and I can shoot 3 different shots to those 8 locations. And there can be a high power shot with some sort of a spin on it, or just a low lob. We can go down. We can select where those 8 shots go, and that's a basic start and stop page. This is the shot sequence for the different groups, the beginner, good, or whatever. You pick a shot and you put it as you want it to go here, 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 and then it'll create that sequence for you and repeat it. Let's see. This is it's the cancel out page that comes up. This is just time between shots, how fast you want it. Maybe every 3 seconds up to whatever. So that's the screen gibberish. That's about the gist of it. I'm going to put a little video in of the. I'm going to put a little video of it shooting and Ashley hitting the ball back. She hurt her foot, so she's not up to snuff, but she was nice enough to go out and film a little video. Okay, thanks for watching. That's a good one. Okay.